Welcome to Algebra 1. The learning goal for this episode is to learn how to add and subtract rational expressions. If we let a, b, and c be polynomials where c is not equal to 0, then a over c plus b over c equals the quantity a plus b over c. Similarly, a over c minus b over c equals the quantity a minus b over c. This is what you already know from having worked with fractions. Rational expressions are a more algebraic term for fractions. Let's look at an example. Notice how my denominators are the same. Therefore, we can simply add the numerators and get 18 over 8y. We can then reduce that to 9 over 4y because 2 divides into both 18 and 8. We always want to reduce our answers as much as possible. Let's look at a subtraction example, where again the denominators are equal. So we subtract the numerators and keep the denominator the same. Notice though that when we subtract we need to be careful, as we need to subtract the entire second numerator, which means we'll need to distribute that negative sign. Now we combine like terms to get 3x plus 4 on the top and x squared minus 2x plus 2 on the bottom. Since 3x plus 4 doesn't factor, we're done. This is as simple as we can get it. Let's try a third example. In this example, however, our denominators are not the same, so we'll need to get a common denominator. The common denominator for the constant parts, 2 and 5, will be 10. And the common denominator for the variable parts, q and q to the fifth, will be q to the fifth. Therefore, my common denominator for the entire thing is going to be 10q to the fifth. So I need to multiply my first fraction by 5q to the fourth over 5q to the fourth in order to get my common denominator of 10q to the fifth. For my second fraction, I'll need to multiply by 2 over 2. Notice that I'm really just multiplying each fraction by 1 in a fancy form, so I'm not changing the value of my expression. When I multiply, I get 15q to the fourth over 10 to the q to the fifth plus 14 over 10q to the fifth. I can then add those numerators to get 15q to the fourth plus 14 all over 10q to the fifth. Note that I cannot combine 15q to the fourth and 14 as they are not like terms. Since 15q to the fourth plus 14 doesn't factor, I'm done. Let's try another subtraction example, this time with unlike denominators. My common denominator in this case is going to be 7x times the quantity x minus 4 because those two things have no factors in common. So I'm going to need to multiply the first fraction by the quantity x minus 4 over x minus 4 to get that common denominator, and my second fraction by 7x over 7x to get my common denominator. When I multiply the x minus 4 times 9, I get 9x minus 36. And when I multiply 3x times 7x, I get 21x squared. Since it's subtraction, I then get 9x minus 36 minus 21x squared in the numerator, and then my denominator is simply 7x times the quantity x minus 4. In my numerator, I can factor out my greatest common factor of negative 3, but that's it. I can't factor it anymore. So this is as simple as I can get my answer. Let's try another example, this one with trinomials in the denominator. Before we try to get a common denominator, let's factor those denominators. For the first fraction, we get the quantity x plus 3 times the quantity x plus 3. And for the second fraction, we factor into the quantity x minus 8 times the quantity x plus 3. At this point, we should notice that those two denominators have one factor in common, the quantity x plus 3. Which means our common denominator is going to have as factors the quantity x plus 3 twice and the quantity x minus 8 once. Therefore, I'm going to need to multiply my first fraction by x minus 8 over x minus 8 to get that common denominator, and my second fraction by x plus 3 over x plus 3 to get the common denominator. When we multiply our first fraction, we get x squared minus x minus 56 in the numerator. When we multiply our second fraction, we get x squared minus 2x minus 15 in the numerator. And our common denominator is what we already determined, the quantity x plus 3 times the quantity x plus 3 again times the quantity x minus 8. Now we combine like terms in the numerator to get this. If we could factor the numerator, we would, in order to see if we could divide out any factors. But the numerator in this case does not factor, so we're done. Now for our guided practice section. We're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step I'm going to prompt you the question you should be asking yourself. Then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. So for this problem, our first question is, what are we trying to do here? What we're trying to do is subtract these rational expressions. How do we do that? We need to determine our common denominator. In this case, our common denominator will be 20y to the third, because 20 is the least common multiple of 4 and 5, and y to the third is the least common multiple of y and y to the third. So we need to multiply our first fraction by 5y squared over 5y squared to get that common denominator, and the second fraction by 4 over 4. Now what? Now we go ahead and multiply and write our expression as one fraction with a common denominator. Now what? Since the numerator doesn't factor, we're finished. This is as simple as we can get this one. Let's try another one. What do we do first? First, we want to determine our common denominator. How do we do that? We need to factor our denominators. What's next? Next, we multiply each fraction by what it's missing in order to get our common denominator, which is going to be the quantity w plus 7 times the quantity w minus 7 times the quantity w plus 3. So we're going to multiply our first fraction by w plus 3 over w plus 3, because that's what it's missing in the denominator, and our second fraction by w minus 7 over w minus 7, since that's what it's missing in its denominator. Now what? Now we actually go ahead and multiply this out and then write it as one fraction with the common denominator. When we multiply the quantity w plus 3 times the quantity w plus 1, we get w squared plus 4w plus 3. When we multiply the quantity w minus 1 times the quantity w minus 7, we get w squared minus 8w plus 7. So what do we do next? Next, we combine like terms in our numerator to get this. Are we finished? Not quite. We can factor out our greatest common factor of 2 in the numerator. But that's all the factoring we can do. So now we're finished. We always try to factor the numerator as much as we can to see if that helps us simplify our expression. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video now, work out the problem, then press play to check. Here is the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this one. Pause the video, write down this problem, and work it out in your notebook. Then press play to check. Please pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to add and subtract rational expressions. We did that by learning to factor the denominators and then find a common denominator. We then multiplied each fraction by the missing factor, top and bottom, added or subtracted the resulting numerators, and combined like terms. We then attempted to factor the resulting numerator to see if we can simplify our expression.